related to our dynamic systems, but here I just doing the numeric calculation. So here is y double dot minus 2y dot minus ay equal to 1. Y0 equal to 1 and y dot 0 equal to 0. Okay, so this one is a dynamic system, but it's not realistic in terms of our vibrations, because here the coefficients corresponding to C and K both negative. But here we just practice directly, so I don't care it's really physically reasonable or not. Okay, so with this one we want to solve for yt. We want to determine the time, the solve for the time domain expression for y. And here, we look at the equations here. It is subject to the non-homogeneous term. So this term, right now everyone should know this term will contribute to the steady state or non-homogeneous solutions. And also we have non-zero initial conditions. So that term will contribute to transient or homogeneous solutions. So in this way, the total solution in your mind, in terms of what you have learned, must have two terms here: the homogeneous solution or transient solutions, or plus the steady state or homogeneous solution, two portions in concept. Okay. But using the Laplace transform, we are able to ignore such initial identifications, because using the Laplace transform, if doing the process correctly, the whole process inherently embedding the two terms simultaneously. Okay, so we see how can we do this one here. So to do this, the first one, we take the Laplace transform on the Gaussian equations, and which means Gaussian equation 1. Okay. And to do that one, simply we have to utilize the table. So this is the first derivative, and this is the nth order derivative. We simply right now using the two informations. So in this way, again, we can use this one. So yt, let me define as a y capital S. Okay. So in this way, y dot t. And for first derivative, we use this information here, and that is s times y. And s multiply is corresponding the Laplace transform minus initial conditions, initial positions. So that is minus y0. So in this case, that is sy minus 1. Okay, and then we prepare for the double derivative. So that one, you look at this one, this is an nth order derivative, so we utilize these informations. So that would be s squared and y and minus s times y0 and minus y dot 0. Okay, so that will become s squared minus y minus s. Okay, so we plug in those things here. So therefore, we take the Laplace transform of y double dot minus 2y dot minus ay equal to the Laplace transform of 1. So therefore, from here, we simply plug in all the information. So that means s squared y minus s minus 2 times sy minus 1 minus 8 times y. Okay. So individually, I plug in the our calculation into the y double dot dot and y and corresponding Laplace transform form here y. Like this, okay. And then on the right hand side, that is a Laplace transform of 1. So from the table, the corresponding is 1 over s. Okay, so on the right-hand side of the equation, I utilize this table, this line here. Okay, so that is 1 over s. Good. So in this way here, here sometimes to save writing, I simply drop the of s. Okay, just for quick writing. So in this way, I collect the y terms with other things else. So here, y on the right-hand side as squared minus 2s minus 8 will be equal to s, and then plus s plus 2 minus 2. So basically from here to here, I simply remove this term and corresponding this term to the right-hand side and become like this. You good? Okay, because my goal is to determine what is the expression of y. So that is actually y of x. Let me separate. Let me separate, will be easier. Okay, so let me separate into this individually. You good? Okay. So before going to the next step, would that be too quick? So do you need me to slow down a little bit? I can wait. Okay. So before I move on the continuous calculations, here probably I can explain why the Fourier's, why the Laplace transform taking care of the transient solution and steady solution simultaneously. And here is the explanations. You can see right now I use the blue line to highlight the two terms. The two terms are regarding the influence from the initial conditions. You look at here. This term is minus s is from here. This term is from here. Can you see it? So here I highlighted is the coming from the initial conditions. So once I move to here, the two terms, or simply combining these terms, is the influence from the initial conditions. Okay, and how about for this term? The 1 over s is coming from here. And 1 over s is actually coming from here. So that 1 over s representing is the Laplace transform of our forcing term or particular solutions. So that means this term corresponding is the Laplace transform of the particular solutions or transient solutions. Good? So here I pretty much we clear. If we plug into the Laplace transform the table correctly, then basically what we are doing is to combine the calculation for the particular and the transient solution simultaneously. But here, this is an important concept. You should be able to have a better knowledge than most of the. That is my duty to tell you this. Okay, that's my duty. So, you good? Okay. So keep this in mind. So eventually, once we solve the two terms, then basically we answer the questions right away. Okay. So here we can decompose. So we do this carefully. So y over s. So let me rewrite this one. Let me rewrite this one. We know that for s squared, minus 2s minus 8 can be factorized by s minus 4 and s plus 2. Okay, I utilize this factorization. So this is s, I have s minus 4 and s plus 2. And let me use the two different powders. And plus, this is s minus 2 and s minus 4 and s plus 2. Okay, so let me distinguish the push terms about which. So is this one. In a similar way, and we can solve for those kind of terms individually. So for this term is equal to, we can factorize s and s minus 4 and s plus 2. So this one, again, we can factorize using ABC. Okay, and we determine ABC individually. And again, we can exercise. So in this way, if you do this carefully, so A should be equal to, so right now this is our Fs, S minus 4 and S plus 2, and multiply with S when S equal to 0. If you plug in your note in the previous example, okay, now will be a good time to turn over to apply the previous concept to here. Again, I want to determine A. In this way, I have A stand out. To stand out A, I multiply, okay, this time let me write here. Again, you can see this. Our purpose to determine A is to have A stand out. To achieve that goal, you multiply the both sides with S. Such way, the A will stand out. And then to make the two terms disappear, that means this term, when we multiply with S, that's S here, S here. So you simply make S equal to 0, the two terms will disappear, making the S stand out. Okay, so under these situations, will be equal to cancel this one. That would be minus 1, 8. Is that right? And what is B? B will be equal to S minus 4 and S plus 2, and that is multiply S minus 4 when S equal to 4. Okay? So that one cancel these terms, and when S equal to 4 is 1/8. And C will be equal to S minus 4, S plus 2, and multiply with S plus 2. Cancel this. So S equal to minus 2 will be equal to 1. 2 times minus 2 equal to minus 12. Okay?
Is B right?
Is B right? B should be
1/24.
Huh?
1 over 24.
1 over 24?
Yeah, because you get
4
1
times
over
6.
S.
Yes, thank you. I knew it.
Then it's right as well.
Huh?
And then check C as well.
Okay, we check this one. When s equal to 2, so that is minus 2 times minus 6, that should be 12. Right? Thank you. Okay, so basically here for this calculation, then we can see that is minus 8 over s plus 24 s minus 4, and then plus c 112 s plus 2. So in this way, we can directly write up so therefore, y over t will be equal to the inverse so inverse whatever the red term here. Okay, so the red term here. So here for the red term, that means corresponding to this one, then basically is this. Right now you can see that is minus 1/8 and times the inverse of 1s and plus 1 over 24 and the plus inverse of 1s minus 4 and plus 112 the plus inverse s plus 2. Right? You good? Right now we have expanded into this. So we want to determine the Laplace inverse of individual one. I put into here. So that one, let me keep writing to here. So that will be minus 1/8. The Laplace inverse of 1 over s, we'll look at this here. And that's equal to 1, right? Okay, the second term, the plus inverse of 1 over s minus 4. And we'll look at this term here. So for this term, when 1 over s minus 4, so a equal to 4. So that the second term equal to e40. And plus 112. The last term, 1 over s plus 8. So here, when using the last term, and here the a equal to minus 2. So that is to the e to the minus 2a. 2t. Be good? Good. Any questions? Okay. So here again, for these portions, again, for if you forgot the kind of hint and the things, and here for doing the detail, I would suggest you simply do just follow up our previous example. You simply write up a little bit more steps and expanding on the both sides. You will see the summarized calculation like this one. Okay. That wouldn't be hard if you just spend a little bit, a few more minutes, just write it up everything. You should be able to see this one. This is a very concise expression for the calculations. Okay. So that is for the right one corresponding is the response corresponding to this one. So basically the right one corresponding is y(s) over t. So right now the colors we've been calculated is for these portions. So right now I want to continue to determine the blue one. Okay, so right now for the blue one, again we doing the similar process. So again, s minus 2, s minus 4, and s plus 2. Again, we factorize into two terms, s minus 4, s plus 2. And again, using the coefficient a, b, c. Okay. So again, a is plus b, s plus 2 times s minus 4, and s minus 2, s minus 4, s plus 2, and s minus 4. Okay, so here let me redo the detailed calculation again. So the first one, I want to determine A. So I simply multiply both sides with the corresponding numerator, become like this. To determine A, I want this term to be disappear. So to get this term disappear, so to get this term become 0, the only chance is to set as value equal to 4. Okay, so therefore, A is equal to s minus 2, s minus 4, s minus 2. Okay, so that's the reason why, based upon this observation, we write it up like this. Under this case, this term cancelled, so that will be equal to 2, 6 equal to 1, 3. Okay, so similarly, the B equal to S2, S4. Okay, in a similar process, you can just do the similar way to write up this kind of expression. You can get this one. So that will be 2/3. Okay, so continue. So that will be equal to Laplace inverse of the blue terms. So that will becomes the blue term will be equal to plus the A is equal to 1/3. B equal to 2/3, so that means here is 1/3 Laplace inverse s minus 4 plus 2/3 Laplace inverse s plus 2. Okay. So again, that has taken the similar form like this one. Okay, so we're plugging, so that will be 1/3 E for a 40 plus 2/3 E minus 2t. You good? So here is we distinguish the terms that contributed individually from initial and conditions and the force terms. But if you like, you can continue to make one more step and you can combine the terms together by doing the summation of the coefficients, But in that case, you simply put everything together, so you won't be able to see which part is from initial conditions, which part is from force. Okay. Should be good, right? Yes.
Would you like us to